In this lesson, we're going to do an introduction to radicals and surds of real numbers. A radical can be thought of to say as any expression that has a root. For example, root 3 is a radical, root 4 is a radical, root 5 is also a radical. But for surds, we say that a surd is a radical that represents an irrational number. A surd is a radical that represents an irrational number. For example, root 3 is a surd, root 2 is a surd, but root 4 is not a surd. This one is not a surd, mainly because it can be simplified to a rational number, which is 2. Okay? So we're going to be focusing more on surds, but the same principles that apply to surds also apply to the whole group of radicals in general. So the next thing that you want to know is how to multiply surds. Okay, let's say you have root 2 times root 3. This can be simplified to root 2 times 3, where we have 2 and 3 inside one root. It's the same thing. And it can be further simplified to root 6. Okay. And furthermore, if let's say you are given root 10, you can write root 10 like this. It is the same as having 2 times 5 inside the square root and having root 2 times root 5. It's one and the same thing. Next thing that you are going to look at is how to divide surds. Say you have root 2 divided by root 3. This is the same as writing root 2 divided by the square root. You have 2 and dividing by 3, and what you get here is root 2 over 3 in one square root. Again, this is the same as say you have root 4 into say root 5 over root 2. This can be written as one whole square root where you have 5 inside and over 2. It's one and the same thing. Right. Once you know how to divide sets, the next thing that you need to know is how to simplify them. Say you have, for example, root 40. We need to simplify root 40 into something that is easier to handle. Okay, so we can write root 40 like this, where you have 4 times 10. And this can be further simplified to this root 4 times root 10. And we know what root 4 is. It's just 2. So we write 2 times 10, which can be simplified to 2 times root 10. Okay. So you need to look out for things like this, how you can simplify a given set. Let's say you have root 27. This can be written as inside the square root 3 times 9. Then we can have root 3 times root 9, where we have root 3, and we know that root 9 is equal to 3, and we can write this like 3 root 3 as your answer. So that's how you can simplify sets. Okay. And one other thing that you need to look at is the distributive property of surds. For example, you can have 5 plus root 3, and you have something like root 2 on the outside. You can actually distribute this root 2 in everything, not the elements that are in the brackets, where you are going to get 5 root 2 plus 3 root 3 times root 2, which can be written as 5 root 2 plus root 6. Okay. Now, one of the last things that you need to know is that these things that we've talked about do not work for addition and subtraction. Okay. So we looked at an example of root 40, and we said that you can write root 40 like this. So but you can't write root 40 like this. Let's say you say root 20, okay, root 30 plus root 10, and say this is equal to root 40. No, you can't do that. You can't say root 50 minus root 10 is equal to root 40. No, this is wrong. Okay. Root 30 and let's say root 5, for example, are different. Cannot be They cannot be added. Okay. But let's say you have root 2 and root 2. This you can add to get 2 root 2. Okay. But if this is just different, you can't add. Let's say maybe you have 2 root 3 plus 5 root 3. This works. You can add, you get 7 root 3. Okay. Even goes the same way for subtracting. You can say 5 root 3 minus 3 root 3 going to give you 2 root 3. It works like that, but not in this way. Okay. So that is the introduction to radicals and sides of real numbers. I'm going to see you in the next video, where we're going to try to look at an example or further expand this concept.